And now, Dee-Ann, if you're ready, let's find out about performance tuning. So I am passing the ball to you.
Thank you very much. I am going to share my desktop once I get my menu. There we go.
All right.
It is nice to be here. Sorry, my...
Just take your time.
There we
right.
go.
There we go.
So, when times get tough, the tough get tuning. Improve the performance of your Linux systems. The keys to performance tuning are, for one, I mean, you don't even know if you've made any change at all, especially beneficial change, unless you know what your normal performance is. The defaults are fine for the average use. You know, I mean, especially in Linux, you know, the distributions have spent a lot of time deciding how to tune the kernel and how to tune everything else for the bulk of their users. You need to determine where your bottleneck occurs. We'll get into that in a moment. Make small individual changes and then note your performance after each change. So we'll talk about tools that you can use to monitor the performance, and you can look and make sure that you haven't actually reduced your performance, because in performance tuning you can actually make things worse. So that's a big reason to actually see, make your change, then look and see if things have actually changed to your benefit. Really the biggest bang for your buck is new hardware. I won't make any bones about that. However, you can tweak performance to noticeable levels by good performance tuning. So there's 4 performance areas of interest. There's the CPU or CPUs, your memory, your network, and your I/O, such as your hard drives. Each area has specific things you want to watch for. A lot of the tools are actually overlapping. So monitoring performance, like I said, you need to be aware of what your normal performance is before you even begin doing anything else for your performance tuning. And we're going to start with CPU performance. Now what I'm going to do in each case, since we have limited time, is I will list on the main slide for each section a list of tools, and then I will focus on one particular tool as we move along. But you can always go back later and watch the webcast again, or ask me and I can send you a PDF of the slides, and you can go back and check out some of the other tools. So VMstat, MPstat, TOP, SAR, IOstat, and PS. What I've noticed is that depending on your Linux distribution, you may or may not have all of these installed by default, so you may have to go hunt down which package has which. And sometimes they're compiled differently for different distributions. So when I talk about particular flags, you might want to take a look in your particular man pages and see if those flags are actually available to you or not. VMstat. We're going to focus on this one because it gives you so much information in so many different Linux distributions, and across different types of performance issues. So for CPU, you can see the section that I've got circled there. That information is all the average across all CPUs. I realize that there's, these days most everything has multiple cores. And the MPstat command that I was talking about actually will show you for each CPU. VMstat 2.4 I've got here, for example, every 2 seconds it takes a sample and it does it a total of 4 times. And that's going to show you, memory swap, I/O system, and CPU. It's got a lot of information there. And the first line is always the average since the last reboot. So if you are looking for immediate information, you're going to want to ignore that first line. So you have the different columns in the VMstat output. The CPU-related information in your VMstat output. The B is for the average number of kernel threads and the wait queue per second, and that's basically what's queued up to go, what hasn't been running yet. CS is the number of context switches per second. A lot of these are really technical terms. You can read about them in the man pages, or you can Google on them. I want to stop and define every single one. but obviously I'm happy to define anything that people have questions about. ID is the time spent idle with no queued local disk. So basically, it's the time spent idle where the CPU is basically doing nothing and it's not even waiting to write out to a disk. The IN is the number of device interrupts per second. R is the number of kernel threads waiting to run. SY is the time it's actually spent running system code. And US is the time spent running user code. User code in this case is anything that's not the kernel. And WA is the time spent idle, but where it's waiting to write to disk cell. So depending on what you're interested in, you can choose which columns to look at to really learn a lot about what your system is doing at any particular time. VMstat minus S has a much more detailed output. In this case, you've got the CPU idle ticks. That's how long your CPU just sits there with nothing to do. The IRQ, how much time it spends dealing with different devices. Again, you've got system versus user. You've got all kinds of information here. Forks the number of new processes. That tells you, how often things are being launched. If it's a web server, that each time somebody connects to Apache, it launches a new Apache server to handle that connection, a new HTTPD. If you're not familiar with NICE, NICE basically allows you to tell Linux that you want a program to run at a higher or lower priority as far as using resources. So if nothing else, with performance tuning, if you have a program that is seriously sucking up a lot of resources and you don't need it to, it's okay for it to run slower, then you can nice it to, or actually in Linux you can re-nice it. You can't do that in all of the Unix OSs, but you can re-nice it while it's already running to give it a lower priority and have it use less of your system resources at one time. Monitoring RAM. Again, you see VMstat. There's also free, top as always, SAR and PS. SAR is a very interesting and powerful tool, but since it's not always installed by default, I wanted to focus on the more common ones. But I highly recommend you check out SAR if you're interested at all in performance monitoring. For the RAM, VMstat minus A gives you more information than without the flag. In particular, it gives you the inactive and active columns. So it shows you how much of your memory is actually actively in use. The RAM-related information for VMstat, again, active and inactive only show up with VMstat minus A. Buff is how much is in use for buffers. So basically how much is in use for, say, buffering your print jobs before they're actually sent to the printer because the printer's busy. Cache, the amount of memory in use for your swap cache. Free, the amount of idle memory. And then the swap, the amount of actual virtual memory, swap space in use. Now, again, with performance, if you're sending a lot of information to swap, then what you're doing is actually using your hard drives instead of your memory, which is much, much slower. On the other hand, when a program hasn't been used in a while, it will go to sleep. And if you do a PS and you look in the status column, you'll see S for sleep. Those are also sitting in swap. So it can be a little bit, you'll have to be careful in assuming that using a lot of swap means that you are constantly overburdening your RAM. If you're not sure, then for that, for that time frame, it's useful to constantly be monitoring your PS output so you can look and say, okay, what was actually running, what was in state S for sleep, therefore it was sitting in swap but not actually, using my resources much, and what was in state R for running. If you have a lot of things running and you're using a lot of swap, then you really either need to reduce your memory usage or you need to add new RAM. You can use VMstat minus SA to get those active and inactive items in there for your RAM-related output. And again, a lot of this is the same information from before, but it's in a more human-readable format. you don't have to constantly translate what those columns mean. Monitoring network performance. NetStat gives you a lot of information with a lot of different flags. IOStat, that's really more for your devices, like your various network-based devices. And TTCP is an interesting tool that you may find worth checking out. Useful DepStat flags. I would say the big three are A, I, and S. A, to basically see all of your listening and non-listening sockets. That will basically give you just this massive list of, here's what all my sockets are doing. I shows you all your network interfaces in a table. The picture on the bottom you can see is an IA, so it's showing you basically at the top it's got all your network interfaces. And then -S is the summary statistics per protocol. That's the one on the right. So if you really want to see what's happening for every single network layer protocol on your system, then you can use NetStat -S and really dig in there and see where your traffic is. Monitoring I/O performance becomes an interesting exercise because it's going to be slightly different in some cases between different kinds of media. Your I/O also may be network-based media rather than directly on the server. So IOStat, VMstat, STAR, and Bonnie. Bonnie++ is an really interesting tool for taking a look at your drive performance. And NFS-stat is a way of watching your NFS performance over the network. IOStat with the -X flag, to me, is the most useful version of that program. It gives you information like how long it took for your device to serve up the iOS request responses. So how long did it take to write to the drive? The average sector size of the requests, the average queue length, how long did things wait before they were sent, the read requests, all kinds of information. The percentage of CPU time spent issuing I/O requests. There's a lot of information here that you can use to kind of keep an eye and see, what's your system doing when it comes to writing out to drives, writing, reading. Recording information over time. This is really important because if you're monitoring your performance on these 4 different levels, on the CPU, RAM, network, and I/O, then you don't want to just rely on your memory, especially since you're probably not really looking at it every single day. A lot of people won't be. So you want to record this so that you can actually get a feeling for what it's doing over time. And I would say that performance monitoring is one of the few areas where most of the best tools are going to be GUI tools because, well, not entirely GUI tools, but something that can give you graphical output so that you can really, make a lot of graphs and really see what things are happening, the trends over time. Much easier, I think, graphically than watch a bunch of numbers scroll by. But still, you have to keep those numbers so that you can generate these graphs. So make sure to save the performance information over time. I mean, you just might, do shell scripts or whatever you want to do to record that performance information over time. Watch the performance trends over time again. So you want to save it. You can use cron jobs or whatever to have your tool of choice or tools of choice run on a regular basis and save their results to file that you can then process. Determine over time what defines poor performance for you. How maxed out do your CPUs need to be before you want to do something about it? And then you can set up some kind of notifications to be warned. Again, whether you're using cron, shell scripts, whatever kind of tools you want to use for this process. And we'll keep talking about tools here. I happen to be employed by a company called Splunk, so this is my one Splunk section. This is a really good tool for watching performance. What I'm going to do is I'm going to break out of the slideshow and I'm going to pull up a browser. So if your screen goes a little weird, that's why. So Splunk is a client-server software that you can use to basically feed data to and then use it to search and view that data. And what I've done here is I've made a dashboard where I'm watching 4 areas of performance monitoring. I want to make this much bigger because I don't know how big your screens are. So what I've done is I've chosen, this is available memory. So this is watching VMstat, and it's looking at the free memory section of VMstat, and it's showing me over the last 10 hours how much RAM I've had that was not in use. This one is CPU idle ticks. It's also using VMstat, but it's using the CPU idle ticks item that we talked about. You can see that my CPU usage on this particular machine has been pretty consistent as far as how much idle time is available. The lag in my I/O requests, here's where I actually started monitoring this. And then you can see that it went down a little bit and now it's coming back up. If I had this data showing for a month or 3 months, I could really get a good idea, again, no matter what tool I'm using, really get a good idea for how things are progressing. Especially over months, you can really see whether, wow, my CPU use is going up and up and up over these months. I'm going to start having some problems soon. With the swap space in use, again, you have to be careful because sleeping programs could be in swap. So say at this point, which is today at 9 o'clock this morning, at this point I want to know what processes we're running. So in Splunk, what I can do is click on that point in the graph. I want to actually set my time to 9 a.m. I'll put it to 9:01. And now that I have said, okay, this is the time that I'm interested in, I can go over, and because I have Splunk loading up the output of the PS command, let's say I want this second, I can say, okay, what was PS doing, what was my system doing at this time? And you can see all these sleeping processes. So it's not that my system was overtaxed, it's that it wasn't really in use. It was just resting. So I don't have to worry there that my swap was really high because it was just holding a bunch of systems in sleep until it was ready to do something. If you use Splunk with the free Unix application, you can set up Splunk to eat this kind of information and then be able to easily go through it. So now I'm going to move my browser off to the side and take us back to the slides. So like I said, that is one method of watching performance. There's, again, to me, this is a place for graphical tools. XOSView and GKRealm are both really good tools for this as well. You'll also, GNOME System Monitor and KDE probably has something similar. GNU Plot is something you can use at the command line, and that will generate graphs for you. So whatever tool you prefer, make full use of these tools so that you are regularly taking a look and seeing what's going on over time. Some of them are more for looking at what the immediate picture of what's happening on your system, and some are more for over time. These both have their place because if you want to know if you are making changes, like I said, you should look at the normal performance for a change, and then make your change, and then look again. So whether you're using Splunk or whether you're using XOSView or GKRealm, you can be watching and saying, okay, this value changed. It went up. So, oops, I want to roll back this change. This was a bad one. Or look, my CPU use went down. I'm keeping that one. Tuning performance. Tuning CPU performance. There's actually not a lot of, weird geek mojo here to tuning CPU performance. You want to stop the processes you don't need, and we'll talk about some of the daemons and whatnot you can usually get rid of. Again, you want to nice or re-nice processes that are hogging CPU if they are low priority to you. You can use nice or re-nice to actually increase a program's priority and give it more resources if you want as well. But don't slow something down if you're really waiting on the output of that process. If possible, on a lot of servers, you may not need the GUI. The GUI eats up a lot of resources. It's also just another place where, something bad could happen, and it really, when it comes to security as well, don't run anything you don't need. If you're really desperate, recompile the kernel. Again, this is going to be more of an edge case thing, because, again, the distributions have spent a lot of time really refining their particular kernel configurations. So for the average use, the kernel configuration is just fine. If you have other software that you have the code for, that's really, really bogging down your system, you can probably recompile it for more efficiency. And again, I cannot stress enough, whenever you are making changes for tuning your performance, look at the previous, make your change, single change, then look at the results. Always check to see that you have not slowed things down, or at least even if nothing has changed, you can decide whether that particular performance change was worth it or not, because there's usually trade-offs. I built a short list here of common processes to stop. Really, the way I build these lists is I take a look at all the processes, maybe I'll go into etc. rc.d and it.d, which is usually, though it depends on your distro, for most of the distros I use, that's where I'll find all of the launch control programs for these daemons. And then I go through and I look at the man pages and I figure out which each of these, what do they control, what are they involved with, or I might Google for them. And so you just kind of say, okay, am I even using this? You may not, depending on your 24/7 servers, depending on a lot of variables, because I'm all for good power management. But depending on that server, it may not need a lot of power management. That's, sometimes more for desktops. For things like Anacron, there's so many people who've never even heard of Anacron, and it's always running in the background. It's basically a sister to cron, but it's instead of running things repeatedly like cron does, it runs them once. AutoFS, if you aren't using the auto mounter, if you set up that server and you don't even know what the auto mounter is, you don't need AutoFS. AutoFS is basically for when if somebody enters a particular directory and you want that server to automatically load up, say, a CD-ROM to mount it, it will automatically mount it and then it will dismount it when it's done. So if you're not using that kind of stuff, shut off AutoFS. If you're not using Bluetooth, and I would think on most servers you're not, it might even be a big security hole, you probably want to shut off the Bluetooth stuff, so Bluetooth, DUND, those kind of things. And Conman, if you're not using Conman to handle remote consoles, and if you are not explicitly doing this, like you haven't done it on purpose, then you're not using it, because it's not the basic default console management stuff. So again, look through and find all the processes you're not using. Be sure to both shut them off now and to make sure they will not start up again at a reboot or changing any run levels. And that can actually have a significant fix for your CPU bandwidth. Tuning memory performance. There is a kernel tool called syscontrol. If you've ever looked in the proc and sys base directories in Linux, these are actually not part of your physical file system. These are actually a virtual file system in use by the kernel. It's where all of the kernel settings are. I don't typically recommend that you go in. You can actually just go in and edit those files to change your settings. I don't highly recommend it. For one thing, if you do that, it won't persist. It will go away whenever you reboot. But also, if you just go around blindly changing things, I mean, this is your kernel. It's like going in and changing the engine of your car while you're driving down the street. With syscontrol, syscontrol is an interface for doing this. It's just a command line program. You can change things with the syscontrol command, and that would be like editing a file, so that just changes it once. So you're going to do that when you're basically trying things. And then you'll change it in syscontrol.conf when you want to keep it on purpose, or keep it per reboots. To find the documentation for syscontrol, this is, for some reason, they make it difficult. I don't know why. But if you have the kernel source installed on your system, then you can go into the directory for your kernel in the documentation directory in the syscontrol subdirectory. Otherwise, you can go to linuxhq.com, kernel, go to whatever version that you happen to be running, in this case, 2.6, that's the latest. And then you can look in the documentation directory there, and you can look at the information there. What I did was I downloaded the tarball, and I basically unpacked it so that I could look at the documentation. And we'll take a look at it in a bit. Tuning CPU performance can often also free up some RAM, because if you've just closed a bunch of daemons you're never using, not only are these daemons not using your CPU, they're not touching your memory either. They're not sitting in memory. So a lot of these performance things interact with one another. And again, always look at performance, change one thing, and then look at it again and make sure you have not slowed things down. So again, with syscontrol, for the CPU stuff, most of the stuff is going to be under the VM.items. And the first item in the syscontrol output, the whatever dot, corresponds to the subdirectory, so /proc/VM. Or in this case, proc sysvm. It depends on how your file system is ordered. Again, you use syscontrol to change it immediately. You use syscontrol.conf to change it permanently. In syscontrol, trying to remember if it's flush nmap pages in syscontrol, then VM flush nmap pages. I think it's VM flush for all of them. Syscontrol is well worth getting familiar with. You're going to hear about it a lot. Tuning network performance. A big one is damaged network hardware. One thing you can do is you can go through and check all the Ethernet cards and look at all the settings. See if maybe you've got a card, a really cheap Ethernet card is probably not giving you great performance. Not that you need a highly expensive one, but a $5 Ethernet card is probably actually going to hurt your performance. You could use programs like ETHTool to see that your Ethernet cards or whatever NICs you're using are set to the right speeds. You'd be amazed. I taught a class once where the room had gigabit Ethernet cards, and they'd set it to one of the lowest speeds possible. I don't know what was going through their heads, but if your NICs aren't set to the right speeds, you're seriously hurting your performance. Why did you spend the money on good NICs? Again, syscontrol. Things you want to watch for networking are MTUs, fragmentation, and TCP parameters. And MTU is the minimum transfer unit. I don't recall. And that's basically, transfer units are the size of the packets that are being sent, essentially. And so you can actually choose how big or small these are going to be. And just like there is traceroute, there is, I'm totally spacing on it, but there's a similar tool that will actually show you the packet size per hop instead of how long it took per hop. And what you can do there is you can see basically what the smallest packet size is. And then you can tune your packet sizes so they're equal to that smallest packet size. What that does is it saves you fragmentation. So with fragmentation, what's happening is that as these packets are traveling, if a really big packet comes into a place where they only take really small packets, they have to break that packet up, they have to, send it through, then another site has big things, and so it's, so things are being reassembled all the time, and that's overhead. Especially, within your own site, within your own network infrastructure. You make sure all your MTUs are the same size, and you can really improve network performance that way. There's also TCP parameters, things like keep alives, retry limits. You can tune all that stuff with syscontrol. And so you can choose, how many, because again, this is all overhead. And again, there's trade-offs, because if you, lower the keep alives and you lower the retry limits, then some of the spottier types of services, or you may get things that start to fail, and of connections that aren't being made. So again, when you're doing your performance monitoring as you tune, you want to look and see what the performance was before, make your change, and then look at it after. But in this case, you're also going to want to observe over time, make sure that you haven't broken anything, over the next few days after you've made these changes. If you find that suddenly a service that used to connect fine all the time before is suddenly dropping connections, then you may want to retune the parameters, maybe go halfway back up or halfway back down, depending on what you did. So there's a bit of an art to performance tuning. I/O performance. Again, syscontrol is going to be a big tool for this. The documentation will be spread out between the syscontrol documentation and the other parts of the kernel documentation for the various file systems and whatnot. So file system stuff and VM stuff, because again, I/O performance kind of is going to touch everything because it's dealing with your devices. With file servers, so like web servers, Samba servers, things like that, one thing you can do is set off A time for the last time things were accessed. It may not really need to record that information, especially if you're doing file system auditing of any sort. You're recording that information elsewhere, and you're just having overhead with the actual drive. So what you can do is in the etc.fs tab file, you can go in for that particular file system mount and add the no time option, which will disable the access time. And then you're going to need to remount to activate that. Tuning NFS performance. These days, probably most people are using NFS version 3, but it still bears mentioning that NFS version 3 is a lot more efficient than version 2, performance-wise. You can also, for each individual NFS mount, go in and, or globally, have all the read and write block sizes set to these particular block sizes. These are a nice, typically efficient, because basically it's, again, it's just kind of like packets. Whenever it's, it's sending stuff through the network to the hard drive, it's going to send, read size is going to pull out, 496 blocks. Write size is going to send 8,192 blocks. And these, for some reason, are fairly efficient numbers to use. If you have problems with the network performance, then that's, then fixing that will tune your NFS performance as well. If the NFS server itself is overburdened, then tuning, CPU and RAM might help as well. Keep in mind there are only so many simultaneous read and write operations that can be done at one time. If your NFS drive or drives are really busy, then it may help to spread that out some more. Add another drive, add another, put another NFS server on another machine. So, be creative when you're tuning your performance. So summing up, we'll have lots of time for questions. So I just wanted to reiterate, it really bears repeating, because we're all lazy, and it's easy to avoid, just say, oh, I don't need to do this, but it really is important. You want to become familiar with your normal performance. Not only will this tell you when, it's looking like you need to start thinking about either getting new hardware or tuning performance, or maybe splitting various functions across a couple of different servers that you already have rather than leaving it on just one. It lets you be proactive in dealing with the issues. Remember that the defaults are fine for the average use. If you have a multi-purpose server, then a lot of the defaults are probably fine. If you have a really specific use server, then you probably can do a lot more with tuning. Determine where your bottleneck occurs. So that's CPU, RAM, network, and I/O. Make small changes. I really recommend making one change at a time. And then, look right before you make the change or right after the change and see what has happened. See if you have made the performance better or worse. If you really haven't changed the performance, as long as you haven't traded off anything much, as far as, maybe giving up a little, feature here or there, it may be worth leaving it there for a while and see if over time, if it helps you. It's certainly, as long as it's not hurting you. So really, these are all the keys to performance tuning in Linux. So do we have questions? I believe Catherine was going to read off questions to me, but what I'm going to do is I'm going to close my slides so I can also see the chat window.
Okay. Hey, Dee-Ann, you sure covered a lot of territory there. It was fascinating. So people, if you have your questions, now is your chance to ask them of Dee-Ann. I think people, they haven't been coming in while we've been talking, so someone's asking me if this was recorded. Yes, we are recording this, and we'll make it available shortly. I'll send you an email when the recording is available. Usually it takes us a few days to get it posted online so you can see it.
I've got a friend reminding me that it's no A time, not no time. Sorry about that.
No A time?
Yeah, instead of no time.
Okay. Well, questions, everyone. Now's your chance to submit them. And so, Dee-Ann, I was looking over the questions that came in from people before they were logging on, and it seemed that there were a lot of questions about SAN issues related to performance tuning.
Right, storage area networks.
Yes, yes. And one person in particular was asking about performance tuning in a world of virtualization, SAN storage, multi-core CPUs, and the 2.6 kernel.
Right.
So I know that you touched on all of this during your presentation today, but I'm curious, what are the tools that you just couldn't do without?
Me personally?
Yes.
Me personally, obviously, I work for Splunk.
Yes.
So Splunk to me is a no-brainer because I can feed anything to it I want. I made that simple dashboard. It wasn't a big deal to make, and I can just go look at it whenever I want. It's a little distracting to be able to see the chat too. But also, obviously, all of these tools are feeding in to Splunk for me. So the Unix application, for example, VMstat, IOstat, it's running about, I think, 10 different of these performance tools, monitoring tools. And it's basically running them on a regular basis and sending the output to Splunk. So that, without those tools, I wouldn't have the data to look at. You could get it directly from proc if you really wanted to be slick and you wanted to build your own tool and that basically looked at the directories, looked at proc and whatnot, because that's where these tools get everything. But really it's a matter of picking which tool gives you the closest format that you find useful, and then picking which tool gives you the best monitoring output over time that you find useful. For me, again, I'm biased. So.
Okay. Well, here are a couple good questions that have come in. One, John is asking, are you going to be releasing a book that will cover these topics as well as things relevant, additional topics relevant to this?
I've done about 15 books over the years, and I'm kind of taking a break right now.
A lot of work.
That's a lot of work, yeah. If a publisher came to me and said, hey, would you do like a performance tuning book, I can certainly consider it. If anyone wants these slides, I don't know if I send you a PDF of the slides, I don't know if you have a place to post them. But people could email me. I will put in chat my email address.
Okay. And you know what else is? Have you ever tried using SlideShare? It's an excellent resource for sharing slides.
Oh, okay.
But and let me see. We have a couple other questions. Victor is asking, can you offer options for web server monitoring?
There's a lot of, I wouldn't even know where to begin because that's not really my specialty. I'm more of a generalist. But I mean, there's just so many web server monitoring options out there. If any of our 65 attendees would like to suggest anything, then you're certainly welcome to. But I can't think of anything off the top of my head. I assume that we're talking about Apache. We may not be. We may be talking about WebSphere or something. But I mean, there's just a lot of tools out there. I mean, another useful thing for performance monitoring, especially if you're doing something like web servers, is people will get a tool that lets them really hammer on the web server that will basically generate a lot of traffic on the server, and they'll see how it reacts, and it helps them figure out where their bottlenecks are.
So we got a couple comments from that. Ben says that WTOP pulls excellent Apache performance data, and Joshua said that Apache's built-in server status is also useful.
Excellent.
And we have a gentleman participating in this at 4 a.m. down in Australia, and he wants to know what you think about Ganglia.
You know, I really don't know much about Ganglia, unfortunately. Because I'm not doing books anymore, I'm not keeping as up on things as I should these days. Again, if anybody has anything you want to say about it, one of us can certainly read it out, but I'm not really familiar with that one. If you want to email me, I can go take a look and tell you what I think.
Okay. And here's another question from John. He says, regarding Nmap compared to ISOF,
right.
And excuse me if I don't pronounce these things correctly, he finds that ISOF tells the truth more than Nmap, whether he specifies SSPO or not at all. And he wants to know, have you experienced the same phenomenon?
Nmap is always a kind of amusing thing to try. That's LSOF, by the way, which is list of
LSOF.
Okay.
Oh, sorry. Thanks,
That's
John.
Okay. You're not exactly a Linux admin, so that's all right.
I could be.
Oh no, I'm not saying that's bad either. I'm just saying. But yeah, LSOF minus I basically shows you the open network stuff. The interesting thing about Nmap is because it goes out and it probes everything. It's a great way to get your network security people all worked up and coming to yell at you. When you teach classes on a corporate site, that's always an interesting thing to run into. I hear some people say they don't trust LSOF, so it's interesting to hear someone saying the reverse. To me, I mean, ultimately, if you observe that one tool is more accurate for you than the other, I mean, stick with that. It may be a way that the tool is compiled for that system. It may be something about the distribution. But I've heard variable things between LSOF and Nmap.
Great. Okay, more questions. Oh, let me send this. John is saying some feedback on that. He says, specifically, when verifying what open network sockets, it seems that Nmap doesn't show the same results as LSOF.
Right. Right. Yeah. I've heard some people say that they just find LSOF didn't give them what they considered reliable results. I don't recall hearing so much that about Nmap. So LSOF, I don't know. Maybe LSOF gets confused about things. Maybe there's a lag. Maybe it's not quite up to date when you run it. Maybe, I don't know how often it checks things, whether it does it right when you run it or whether it's got something going in the background. It's really hard to say. I am not exactly sure why that is. I just know that I've had people tell me they don't consider it 100% reliable.
Okay. And here's another good question. Thank you, John. We have a couple questions here. One is from John, asking, do you recommend a network utility that would definitely provide consistent, reliable feedback, or perhaps you could recommend proper switches to use with Nmap instead?
If you want to email me about that, John, I will take a look at at that. Unfortunately, I haven't used Nmap in quite a while, so I need to kind of fiddle with it.
Okay. Now here's a totally off-topic question that I've actually got from a few people. Someone asking why we're using a proprietary platform for this
That's
webcast.
actually an excellent and fair question. I have been a member of the Linux community for a long time. My primary desktop is a Linux box. However, this forum software doesn't work particularly well on Linux, and I could not get it to work on my Linux box. So I have a Mac for work, and so I am running it on my Mac.
And as for the software that we're using, WebEx, we have tried using a few others, but we get large crowds for these webcasts, and so far it seems that WebEx is best able to deliver a consistent experience for people logging in. There are still some issues, granted, but we're just settling for, or so far it's the best option that we've found. So.
Yes, this is an amusing discussion we had at first. She's like, I apologize, but it's probably not going to work on Linux.
Right, right.
And so basically I was just using my work tools.
Okay.
Yeah. So I see another question, cross-platform networking. So tracking down bottlenecks between Linux, Windows, Mac. Keep in mind that OS X is running Unix under the hood, so you could probably use a lot of the same tools in the Mac. One person is suggesting groundworkopensource.com for monitoring, by the way. For tuning cross-platform networking, I mean, some of the stuff, for example, doing the traceroute variant for packet size, I mean, it doesn't matter what everything's running because it will actually, it's just looking at the packets. A fun thing with Nmap you can do, I believe, is see which OS, to a point, which OS each system reports that it's running. It's not necessarily the same thing as what OS the system is actually running. I haven't been a Windows user for years and years and years, so I am about the worst person to ask for tuning stuff on Windows. Sometimes you'll find Windows versions of programs that come from the Unix world. But for the Mac, a lot of the same stuff is going to be there. And the Mac also has some built-in stuff that will let you watch the immediate stuff that you're doing, your immediate changes.
Good. Now, we have a little more time for questions. If anyone has a particular problem that you want to get advice on, now is your chance. Oh, they're coming in.
RAID, you have to decide. Again, I mean, a lot of my answers are it depends, and I apologize for that. But I mean, everything really does depend on what exactly you're doing. I mean, obviously with RAID, RAID 0, there's no redundancy, really, for example. So you've got all these issues with RAID. So what I would first do is decide what I was trying to accomplish with the RAID, and then, I mean, really, I would test it, try a few settings. Obviously, not everyone has that luxury to be able to do one setting, hammer on the system, to do another setting, so you have to kind of rebuild things. But it's really, even for web servers and high traffic web servers, mostly serving media, I would be more concerned about redundancy, backups, mirroring, all that kind of stuff, really. I will say with RAID that hardware RAID will always beat software RAID in performance. In Linux we can do a lot of software RAID, but it's always going to be slower.
Okay. And then Nick is asking if anyone can recommend any tools for bandwidth monitoring without requiring the installation of MRTG on a host.
Well, again, you can do, I mean, some kind of bandwidth monitoring by using, by using some of the basic tools I talked about. because if you were, say, on the system that is your gateway to the internet, if you're monitoring that particular interface, then you can use, something pretty simple. The multi-router traffic grabber, MRTG, is a bigger tool and is fancier, and it will give you a lot more information. Also, a thing I should mention about performance tuning is that just the fact of observing performance means you're running something to watch it, which means you are slightly dampening performance. So that, a lot of these tools are really small. Okay, I'm seeing, I think somebody's asked something twice. I want to make sure. How often do you take system performance samples? The more often you take it, the more you're actually affecting performance. Schrodinger's cat, you look at the cat and you've changed the cat. It really depends on how often, how much, how many resources does your tool that is recording the performance use? If you look at the Unix app in Splunk, they're all running kind of at different intervals, and that's really just from experience. For some cases, every 10 minutes is fine. In some cases, once every 5 seconds. You just want to try not to bog down the system. So maybe you can do your performance monitoring and actually monitor your performance monitoring as well.
Let's see. Philip is asking, in your experience, how accurate is SAR in gathering info in all areas?
I haven't really, nobody's ever commented to me. I used to teach a lot of classes, and so I would have people comment to me if they found particular things unreliable. And I don't recall hearing anything bad about SAR. Mostly people just weren't aware of it because it's often not installed by default. If somebody's saying that they don't think an agent has to be installed for the MRTG.
I thought he said PRTG. Is that something?
He said PRTG, but I'm thinking he probably meant MRTG.
A typo.
Yeah.
and did you see the question from Todd Campbell?
Yep, put that in crisis.
Yes.
Yeah. So if you're not already monitoring performance, take that as getting a mini lecture from me that it's always good to monitor it first. But what you can do is, if you're looking at a server that's slow, use these same tools and see, which of the things seems bogged down. Is the CPU really pegged? And you used to be able to just look at top and say, okay, load average of 2 is starting to crawl. But because of multi-cores these days, it could be a load average of 10 and everything could be fine. So you want to both use your tools and use them with the context in mind. If you're actually on the server looking at it, you can tell if it's running really slow. But you can look and see, how much memory is in use, how much swap is in use, how high is the CPU being taxed. If all that stuff is fine, then you want to look at the network and you want to try the I/O. Try doing stuff that will cause writes to disk. See if it's really laggy and slow. So you're basically going to have to do a little investigation there, but you usually use the same tools. You just won't have the data history to look at as well. And then once you've done that, then you can say, okay, the CPU is really pegged. Is there a runaway process here, or the memory is just completely, crushed? Maybe there's a memory leak with something. You can use top and see what's using the most CPU, what's using the most memory. So that's probably where I would start. And you kind of just go from there. Once you've pegged, which program is involved, you relaunch it, you watch it, maybe you want to monitor that program, see if its memory use starts to climb. Or if you really need this program, but the CPU is just really being killed, then you're going to want to go through and say, okay, what other stuff can I get rid of? So that's pretty much where your decision tree would look like. Somebody's saying that Cacti is a really good and free tool for network and bandwidth monitoring.
Yes, there was a few people were exchanging their opinions about Cacti, and
Nagios. Oh, he actually meant PRTG, not MRTG. My apologies.
Good. We have some good laundry list of tools here.
Yep.
So this is really nice to see that people are sharing this information.
For backup,
Yeah.
in Linux, and probably, I don't know how much of the rest of the Unix world, rsync is what a lot of the backup tools use underneath the hood. I really like rsync. rsync will let you do things like compress the data on the fly before sending it to the backup. It can do partial updates. You know, you can tell it to update, and it will only update the parts of the files that need to be updated. It's a really slick tool. It takes a little practice. There is I think it's the N flag that basically says, don't actually do it, just show me what you would do. I highly recommend using this flag at first while you get used to telling it which directories and files and everything. But cron and rsync is really sufficient for a lot of people. You want to be careful if there's really large files. Sometimes rsync gets a little screwed up there, and then you might want to use SCP, secure copy. But rsync in general is a really, really nice, and again, most of the backup tools are actually using rsync under the hood. Somebody else is saying that Cacti coupled with scripts to graph, like JBoss, MySQL, Apache Network, and Nagios. So you're hearing a lot of the same things over and over, Cacti and Nagios.
Right. Right. And I want to tell everyone, you can, if you want to save this chat file for reference, you can do it. Just go to your file menu in the webcast or before and do save, and you can save the chat. It'll save it as a text file. And there's a lot of good information in there. So you probably want to do that.
Yeah, it looks like.
So it's 11 o'clock. We've taken about an hour out of the day, and this has been a very, very informative presentation. I thank you very much, Dee-Ann. And
thank you.
Our group enjoyed it. And so I think we'll just call it a day now. And as I said before, we're recording this, and it'll be available later. And Dee-Ann has also said that you can contact her directly with any questions. Do you want to tell them what your email address is?
It is DEE@splunk.com, and I will be happy to send you a PDF of the presentation. Maybe I can talk to our people and get it up on the site, on the Splunk site as well, to make it easier.
And so when I end this, there will be a brief survey that presents itself in the window after I close the meeting, and we would love it if you would take the survey and give us some feedback on the webcast we had today. And just to encourage you, we randomly select in a totally arbitrary way 3 winners to receive the O'Reilly book of their choice. So, you know, there's a good chance that you can win. So I would encourage you to do that. And Dee-Ann, again, thank you very much, and thank you everyone for joining us today.
Have a good day, guys.
You too.